I earned my degree online at Arizona State University. I chose to get my degree at ASU because I knew that I'd get a quality education, they were recognized for excellence, and that I would be prepared for the workforce upon graduating. To be associated with ASU, both as a student and alum, it makes me extremely proud, and having experienced the program, I know now that I'm set up for success. Learn more at asuonline.asu.edu.
At Arizona State University, we're bringing world-class education from our globally acclaimed faculty to you. Earn your degree from the nation's most innovative university. Online. That's a degree better. Learn more at asuonline.asu.edu.
Welcome to today's deep dive. We're really thrilled to have you with us because today we are on a mission.
A pretty major mission, honestly.
Yeah, exactly. We are going to completely dismantle a very, very comforting myth about artificial intelligence.
It's a myth we all want to believe, I think.
Oh, absolutely. It's this idea of the human in the loop. You know, we love to imagine that somewhere out there in some high-tech control room, there is a human being sitting at a desk, and they just have their hand hovering over this giant red S.P button.
Right, the ultimate fail-safe.
Right. Like if the AI goes off the rails, this person just slams the button and everything pauses. But we're looking at a really fascinating paper today by Jonathan H. Westover, PhD. It's called When the Loop Becomes the System: Rethinking Human Control in High-Velocity AI Environments.
And the title kind of gives away the punchline.
It really does. The core thesis here is a massive wake-up call. Basically, in today's high-velocity environments, that human loop you're picturing, it's largely an illusion.
Yeah, and look, to ease some of the anxiety that thought might provoke, because it is a scary thought, our goal today is to look at this analytically. We're going to explore exactly why that traditional concept of human oversight is failing right now. We'll look at the massive organizational consequences. But, importantly, we are going to break down the fascinating new operational frameworks being built to, give us real control back.
Okay, let's unpack this, because the research makes it super clear that the old idea of oversight is broken just because of sheer speed.
The velocity is the core issue.
Right. It's the analogy I kept thinking of when reading the source is that it's like being asked to proofread a novel while the printing press is literally spitting out 1,000 pages a second.
That's a great way to put it.
I mean, it doesn't matter if you're the greatest proofreader on earth.
Yeah.
It is physically impossible to keep up. Take financial services. We've got machine learning models making credit decisions, detecting fraud, and executing trades.
And they are updating risk scores and triggering margin calls in milliseconds. Yeah, and we should probably clarify what a margin call implies in that specific high-speed context, because a margin call is basically an automated demand from a broker. It tells an investor, hey, you need to deposit more money right now because your investments just dropped below a certain value.
Right, and historically, a human broker made that call. They looked at the market, made a judgment, and picked up the phone.
Exactly. But now an AI monitoring global news might instantly dump a stock and trigger this massive cascade of margin calls before a human analyst has even finished reading the news headline.
Wow, so the damage is completely done before the human is even aware there's a problem.
Completely.
And it's not just finance. Think about software developers. They aren't just typing out code line by line anymore.
No, they're using AI code generators constantly.
Yeah, so throughout a single day, a developer is fielding just this barrage of suggestions from the AI. They have to negotiate hundreds of these micro decisions. Like, do I accept this block of code? Do I edit it? Do I reject it?
The cognitive load is relentless.
It's exhausting just thinking about it.
What's fascinating here is how the governance landscape has had to completely scramble to catch up with that exact operational reality.
Because the rules weren't built for this speed.
Right. If you look at, say, the period between 2016 and 2020, human oversight was framed mostly as this noble aspiration. International guidelines would publish these nice statements saying things like, humans should remain accountable.
Which sounds great on paper.
It sounds wonderful, but it completely lacked operational specifics. They didn't explain the actual mechanics of how a human is supposed to intervene when a machine is making 1,000 decisions a minute.
Yeah, remain accountable doesn't help when the printing press is at full speed.
Exactly. But now that is shifting dramatically. Instruments like the EU AI Act are turning oversight from a polite suggestion into a mandatory design obligation.
Especially for high-risk systems, right?
Right. It's becoming a strict legal requirement that users can override AI outputs. But the operational reality on the ground is still really struggling to bridge the gap between that regulation and technical capability.
Because just mandating oversight doesn't magically solve the printing press problem. You can't just legislate speed limits on human thought.
No, you cannot.
And from what the research shows, this mismatch is suddenly a massive crisis because of these compounding technological drivers. They're all hitting us at once. And it starts with foundation models.
Yes, large language models, complex multimodal systems, that is the foundation of the current acceleration crisis.
Because they're not like the old algorithms.
Not at all. Older, traditional algorithms were rigid. They were entirely rule-based. If X happens, do Y. Foundation models operate completely differently. They have what we call unpredictable emergent capabilities.
Meaning they can do things they weren't explicitly trained for.
Exactly. They can perform tasks they were never programmed to do. It's like hiring an employee to sort the mail, and suddenly you walk in and discover they're translating complex legal documents into French.
That's wild. So how do you oversee a system when you literally cannot predict its full range of behaviors?
You can't. You can't just write a test for every possible outcome because the outcomes are functionally infinite.
Which naturally leads right into the next massive hurdle the paper talks about: continuous learning and adaptation. A model doesn't just stay the way it was when you deployed it.
Precisely. A model deployed on a Tuesday might behave completely differently by Friday.
Because it's constantly eating new data.
Right. It's taking in new data and updating its internal weights. This phenomenon is known as drift.
Drift, okay.
Yeah. And traditional oversight relies on a one-time approval process, like getting a quality assurance stamp before a physical product ships out of a factory.
Right, check it once, it's good to go.
But a stamp of approval is entirely useless if the product fundamentally changes its own design while it's sitting in the consumer's hands.
That is a terrifying thought. And when you take an unpredictable model, allow it to constantly shift its own behavior, and then run it at massive scale, you hit the ultimate wall. Human cognitive limits.
We just have finite cognitive capacity.
Yeah. When you force a human to supervise a complex, shifting system operating at machine speed, you don't get better oversight. You just get alert fatigue.
The human brain simply tunes out the noise to survive.
And I think that feeling connects directly to the reality of anyone listening to this right now. Like, think about your own workplace, whether you're managing complex enterprise software, making high-stakes decisions, or honestly, just dealing with an overflowing inbox that your email client is trying to auto-sort for you.
We all know that feeling.
That feeling of cognitive saturation. Just being utterly overwhelmed by the sheer volume of information that tech is throwing at you. It is a universal feeling. And it's the exact reason why the old human-in-the-loop model breaks down. We just cannot keep up with the velocity.
And because human reviewers are left in the dust by that velocity, we have to look closely at what happens when these systems run wild without meaningful control.
And the fallout is not theoretical.
Not at all. It is highly quantifiable and deeply damaging.
Let's talk about the specific numbers regarding that drift concept you mentioned. Because Westover's research notes that model drift can cause a 10 to 30% drop in predictive accuracy in areas like credit scoring and fraud detection.
And that's within just months of deployment.
Months. So a bank using an AI for credit scores in January could be accidentally denying thousands of totally qualified applicants by April.
And that drop happens silently because the real-world data changed. Economic indicators shift, consumer spending habits change, but the AI is still looking at outdated patterns.
And the human overseers don't notice.
Right. Those silent performance drops lead directly to massive operational disruptions because the humans don't notice the gradual degradation until it's just way too late.
Which brings us to the Zillow example from the text. This is such a perfect illustration.
It really is.
They had an algorithm designed to predict home prices and automatically buy up real estate. But the algorithm completely failed to account for sudden shifts in the housing market.
The drift we were just talking about.
Exactly. And because the human oversight was too weak to catch the miscalibration in time, the system just kept acting on bad predictions at massive scale.
It resulted in hundreds of millions of dollars in losses.
Hundreds of millions.
Yeah.
And the company had to lay off a massive portion of its workforce just because of an unchecked algorithm.
It is a textbook example of a system acting with immense authority, but lacking the necessary human friction to course correct. The system was too fast, and the override mechanism was too slow.
Okay, let me play devil's advocate for a second here. Because the whole pitch of AI in the workplace, right, is that it's supposed to augment human workers. It's supposed to take care of the heavy lifting, the routine data crunching, so you and I can focus on the high-level strategy.
Yes, the promise, yes.
So if these systems are designed to augment us, why does the research argue they're actually eroding our expertise?
That is a really critical tension, and it basically comes down to the psychological impacts of automation. When a system automates routine tasks perfectly 99% of the time, the human operator naturally stops paying close attention.
Because why would you? The machine has it handled.
Exactly. It is fundamental human nature.
Yeah.
But over time, that lack of active engagement causes an erosion of expertise. Consider commercial airline pilots.
Oh, this is a great example.
They rely so heavily on autopilot for the vast majority of a flight. So when an unexpected mechanical failure occurs and they suddenly have to take manual control, they can really struggle to recover.
Because they haven't been actively flying.
They've literally lost the muscle memory of flying the plane.
Wow. So by removing the friction of doing the work, we are losing the fundamental understanding of how the work is actually done.
We see the exact same thing in other fields, too. Clinicians who constantly defer to AI decision support tools start to lose their own diagnostic fluency.
Like reading an X-ray.
Right. They stop looking for the subtle signs on an X-ray because the AI already put a bright green box around what it thinks is the tumor.
They just trust the green box.
Exactly. And software developers who blindly accept AI-generated code snippets can literally forget how to build and debug complex architectures from scratch.
That's terrifying. And the burden seems even heavier for frontline workers, doesn't it?
Immensely heavier.
Like, think about a customer service agent who is forced to use an AI system to interact with customers. They face immense cognitive stress because they feel responsible, and they are certainly held responsible by the angry customer on the phone.
Right. They absorb all that anger.
Yeah, for AI mistakes that they have absolutely no real power to prevent or override. They are absorbing the emotional heat for a system they do not control.
It is incredibly demoralizing for those workers. So we've established that nominal oversight, just having a human nominally in charge of a runaway system, is a catastrophic failure.
The loop is thoroughly broken.
It is. But the landscape isn't entirely bleak. Top-tier organizations are actively restructuring to solve this. It just requires a total paradigm shift.
Right. They're realizing you can't just slap a human at the end of the assembly line and call it a day.
No, that era is over.
The solution demands moving away from seeing oversight as a one-time deployment approval. It cannot be a gate that you pass through once. Organizations are shifting to a model of continuous quality assurance that spans the entire AI lifecycle.
From the very moment data is collected, to the design phase, to deployment, and critically, through constant post-deployment monitoring.
And some of the heavy hitters mentioned in the research really illustrate what this looks like in practice. Microsoft, for instance.
Yes, their approach is very structured.
Right. They aren't just letting engineers build whatever they want in a silo. They've implemented specific risk tiers and cross-functional review boards. So a system isn't just tested by the engineers who built it.
Who naturally have a bias toward their own work. Exactly. It's evaluated by privacy experts, security analysts, domain experts, all at multiple stages before it ever sees the light of day. And then there's JPMorgan Chase. They treat AI with the same intensity as hardcore financial risk management.
They use what they call a 3 lines of defense model.
Okay, break that down for us. What does that actually look like?
That 3-line structure is vital for distributing accountability. The first line is the developers who are actually building the model.
Okay, the builders.
Right. Then the second line is an entirely independent validation team. Their only job is to aggressively test and try to break that model.
Like a dedicated stress test team.
Exactly. And then the third line is an internal audit team that double-checks both the builders and the validators.
Wow.
Yeah, so you aren't relying on one tired reviewer. You are building an institutional immune system.
That's a great phrase, institutional immune system. And a major component of that immune system is technical transparency. The research dives into these concepts called model cards, which were pioneered by IBM and data sheets.
These are crucial tools now. Yeah, a data sheet is essentially like a nutritional label for an algorithm.
That is exactly how they function.
It's so cool. Before you plug an algorithm into your business workflow, you can pull up its data sheet and see exactly what ingredients went into the training data. You can see its performance metrics.
And its flaws.
Right. Most importantly, you can read the allergy warnings, the known limitations, the context where it performs poorly, or any inherent biases. You know exactly what you're consuming before you use it.
And that upfront transparency is paired with relentless, continuous monitoring. Spotify's internal machine learning platform is a prime example of this.
How do they handle it?
Well, they do not just deploy an algorithm to recommend music and then forget about it. They place telemetry on every single model.
Let's define telemetry for a second, because it sounds highly technical to a lot of people. I picture it as essentially setting up digital tripwires, or like tracking sensors all over the algorithm.
That is a perfect way to visualize it. These digital tripwires track the health of the model in real time. They monitor the input distributions, the latency, how users are actually engaging with the recommendations.
So they're watching everything.
Everything. And if the AI drifts from its baseline performance, if it starts behaving erratically or the data environment changes, those tripwires instantly trigger an alert to a governance team.
And then what does the team do?
That team can step in to retrain the model with fresh data, or they can completely disable it before it severely impacts the user experience.
Okay, here's where it gets really interesting, though, because you can have all the telemetry, all the digital tripwires, and the most detailed model cards in the entire world. But if the human interacting with the system is overwhelmed, all of that technical monitoring is utterly useless.
That is the crux of the issue.
The human in the loop fundamentally fails if the interface is terrible.
Interface design is where the rubber meets the road for human control. Because if your telemetry floods a human reviewer with thousands of minor, low-priority alerts, you just trigger that alert fatigue we discussed earlier.
The human just starts ignoring the alarms. It's like a car alarm going off in a city.
Exactly. You have to carefully calibrate the alerting. Look at how Netflix handles this.
What do?
They use an AI content moderation system that processes millions of community posts and interactions, but they use heavily tiered alerts. The AI automatically handles the clear-cut violations and the obviously safe content completely on its own without ever bothering a human.
So it filters the noise.
Right. It only escalates the ambiguous borderline cases to human moderators.
Which is brilliant, because by doing that, they preserve the human's attention for the cases that actually require nuanced, subjective judgment. They aren't burying the human under the easy stuff.
But then you contrast that calibrated approach with the Zillow disaster.
Oh, right.
Zillow's failure was not just a failure of a math algorithm. It was a profound failure of interface and workflow design.
Because the humans couldn't intervene.
The local market experts at Zillow had what you would call a high-friction override pathway. When those frontline workers saw that the algorithm was drastically overvaluing a house, the interface itself made it incredibly burdensome for them to flag the error.
Like how burdensome?
It required too many clicks, navigating too many forms, dealing with too much bureaucracy just to say, hey, this price is wrong. Valuable human signals were actively suppressed because the interface did not empower the human to step in.
It's wild to think that a multi-million-dollar corporate disaster essentially boils down to the fact that it was just too hard for an employee to click a disagree button.
It sounds absurd, but it's true.
But it's not just about the buttons on a screen, right? It's about the organizational culture behind those screens. Workers need to actually feel safe challenging the machine.
Psychological safety is paramount. You can build the perfect interface, but if junior staff feel they will be penalized or ignored for questioning an expensive new AI system that was championed by upper management, your oversight is dead on arrival.
Nobody wants to tell the boss their new toy is broken.
Exactly.
Deloitte has actually recognized this gap. They developed specific AI ethics training programs for their consultants, teaching them how to spot these governance failures. And the UK National Health Service is doing something similar.
Yes, the NHS pilot.
Yeah, they are piloting training specifically to remind doctors that AI is fallible. They are explicitly teaching clinicians, do not abdicate your professional judgment to the algorithm. You are the doctor. The AI is just a tool.
Because without that cultural foundation of safety and critical thinking, the technology just flattens human expertise.
It really does.
And when an AI failure inevitably happens, and they will happen, how the organization responds culturally dictates whether they survive it. Airbnb provides a fantastic model here.
Oh, the SRE stuff.
Right. They conduct incident reviews based on site reliability engineering practices.
And just for context, site reliability engineering, or SRE, is a discipline from software engineering where you basically treat operations as a software problem, and you completely remove individual blame from the equation.
Exactly. Blameless postmortems. When an AI system at Airbnb produces an unexpected outcome, they do not hunt down the single employee who failed to catch it.
They don't look for a scapegoat.
No, they treat the failure as a systemic learning opportunity. They conduct a root cause analysis of the entire sociotechnical system, the algorithm, the interface, the workflow, the training, to figure out exactly why the oversight failed.
And then what?
Then they publish those case studies internally so the entire organization learns from the vulnerability.
That is so smart. It's entirely focused on fixing the system rather than punishing the person. But, as organizations master this current lifecycle governance, they are immediately hitting the next frontier. And this is the part of the research that genuinely blew my mind.
The horizon is moving quickly.
Because we are rapidly moving toward AI systems that are simply too complex for any human being to fully grasp.
The frontier of scalable oversight for foundation models. It is the defining challenge of the next decade.
Well, before we get to the really futuristic methods for handling that, there's a very practical step organizations are taking right now, which is knowing when to pull the plug.
Yes. Sunset protocols.
Right. Just like we retire old hardware or outdated software, organizations are having to develop strict criteria for retiring obsolete AI models before they degrade and cause harm.
Sunsetting is a crucial hygiene practice. But if we connect this to the bigger picture, knowing when to turn a model off is just the beginning.
Right.
The truly complex challenge is what the research refers to as recursive AI. We are entering an era where the sheer complexity of the models exceeds individual human comprehension. So we are having to use AI systems to govern and monitor other AI systems.
Which sounds completely paradoxical to me. I mean, how do you oversee something you fundamentally cannot understand?
You build systems that aggressively stress test themselves. Anthropic, which is a major AI safety and research company, approaches this through red teaming.
Okay, how does that work?
Before they deploy a massive language model, they bring in external researchers to deliberately provoke the AI. They try to trick it into producing harmful, biased, or dangerous outputs while it is still in a controlled lab environment.
They're trying to break it on purpose.
Exactly. And they use those findings to train the model to be safer, essentially encoding safety principles directly into its reward function.
Yeah, the reward function is essentially the internal point system the AI uses to figure out if it's doing a good job or a bad job. So by red teaming it, they adjust the point system so the AI naturally avoids dangerous behavior.
Correct.
But the other method mentioned in the text, which sounds like something straight out of a sci-fi novel, honestly is the experimental debate concept.
The debate method is a fascinating approach to the comprehension gap. Instead of a human trying to decipher an incredibly complex, multi-layered AI calculation to see if it's correct, you have two separate AI systems argue it out.
I am still trying to wrap my head around this. If the AI is too complex for me to understand the math, how can I possibly judge a debate between two of them?
Think of it like a courtroom.
Okay.
You, the human, are the judge. You might not be a forensic scientist or an expert in corporate tax law, but when the prosecution AI presents its evidence for a proposed action and the defense AI points out the logical flaws in that evidence, you don't need to know the complex underlying math.
Oh, I see.
You just need to evaluate the logic and consistency of their arguments to declare a winner.
That is incredible. So we are using the machine's own immense complexity to translate its reasoning into a format a human can actually adjudicate. That is brilliant.
It's an entirely new paradigm of interaction. The human shifts from trying to trace the math to evaluating the logic.
So what does this all mean? If we synthesize this entire journey we've been on today, the old idea of a human sitting at a desk with a giant red stop button is dead.
It is long gone.
The printing press is just moving too fast. Oversight is no longer a polite aspiration. It has to be a rigorous, continuous operational discipline. And the reason you, listening to this, should care about this is that whether you are a consumer applying for a mortgage, a developer negotiating code, or a leader trying to deploy a new tool in your business, the only way we build trustworthy AI is by demanding meaningful human control.
Not just nominal control.
Right. We need interfaces that don't overwhelm us, cultures that let us safely challenge the machine, and systems that are explicitly designed to amplify our judgment, not quietly replace it.
It requires absolute vigilance at every level of an organization. And as we look toward that horizon of recursive AI, it leaves us with a rather profound question to consider.
What's up?
Well, If the future of managing incredibly complex artificial intelligence requires us to rely on other AI systems to evaluate, debate, and monitor them for us, at what point does the human in the loop transition from being the supervisor of the system to merely being the audience?
Wow. That is definitely something to chew on as these systems continue to evolve. Thank you all so much for joining us on this deep dive. Keep questioning the systems around you, and we will see you next time.